Now let's talk about inequalities. Previously, we've been working on solving equations, solving for a variable within an equation, and we've always worked with equal signs. However, in this next section, we're going to talk about inequalities, and this is where we get into the comparison symbols: less than, greater than, less than or equal to, greater than or equal to. And so this video is really an introduction into those symbols and how we would show the solution of an inequality problem on a number line. So first, let's go ahead and look at those comparison symbols. Now, I'm sure you've seen these before, and also you're always going to read left to right. Okay, so for instance, if I had a number here, say 3, and a number here, we would use this sign, which is less than, less than. So 3 is less than 4, okay? If I had, say, 5 and 2, we would use the greater than symbol. So 5 is greater than 2. Okay, now these symbols here have the less than or greater than symbols, but they also have one line underneath. And so really this is a combined less than with an equal sign. And so whoever created this, they decided, okay, we're going to get rid of the top line and we're just going to put it underneath. And so this symbol here means less than or equal to. Okay, so for instance, you could have 4 is less than or equal to 4, and that would work because 4 is equal to 4. You could also have 4 is less than or equal to 6, and that would also be true because 4 is less than 6. The same thing is going to work out here. We know this symbol here is the greater than, and then this line means the equal. So we could have greater than or equal to. So greater than or equal to. So for instance, we could have 8 is greater than or equal to 8 because we have the equal sign here. We can also have 10 is greater than or equal to 4. Okay? All right, so once you get accustomed to using the comparison symbols correctly, then we can represent those amounts on a number line. And so right now we're just comparing one number to another number. When we're working with inequalities, we're going to have number problems similar to when we were working with equations. So for instance, when I had an equation, okay, and I wanted to solve for n, let's say I had 5 plus n equals 10. Okay, 5 plus n equals 10. Our goal was to isolate the n so that the value of n would be on the other side of the equal sign, and we would work out certain principles to move numbers over. So in this case, we're going to subtract 5 from both sides. We're using the addition property, and we're going to get n equals 5. And so n or 5 would be the solution to n in this equation. And by the way, we could have graphed 5 on a number line, okay? And so I'm just going to draw some tick marks, some intervals here. Let's see, we've got 0, 1, 2, 3, 4, 5, 6. And because it equals 5, we're going to draw a solid dot, okay? All right, now this is an example of an equation. We're going to go ahead, I'm going to just give you a view of what it would look like as an inequality, and I'll use the same numbers, just, you know, the only thing we're going to change is the sign here. So let's say we have 5 plus n is less than or equal to 10. Okay, 5 plus n is less than or equal to 10. Now again, we're going to do, and I'll have a video on this, but we're going to do the same, we're going to use the similar principles that we practiced when we were solving for n up here. In this case, it's again, we're using addition principle, so we're adding the negative, and we get n is less than or equal to 5. Now, what I want to show you in this video is how you would graph something like this, okay? And so I'm going to set this problem aside, and we'll come back to it at the very end, because I want to just review how we're going to graph all of these symbols here and give you some examples, and then we'll come back and graph this one. Okay, so if you don't have a template with number lines, you can just make your own. Just draw a line and put some tick marks on, and it should work out fairly easily. It doesn't have to be pretty. We just want to have some number lines, okay? So instead of creating inequality, problems where you're solving for the inequality, I'm just going to give you some solutions, okay? We don't know what the inequality problems are. We just are given the solutions. So let's say that x is less than 2. That's how we would read that. X is less than 2. So this is telling us that the solution for x is any number that's less than 2. Now notice it doesn't have that line underneath, so it's not going to include 2, but it's going to be any number that is less than 2. Okay, so first on the number line, we want to identify where the 2 is and draw an open circle. So here's an open circle, and you don't have to make it as big as I did, but I'm just kind of exaggerating the point here. Now, the solution means anything less than 2. So it could be any of these numbers getting up to 2. It could even be 1.999 would be an appropriate solution, but not 2. So what we would do is we would color in this line or darken it to infinity towards the negative. Okay? Now, if, say we had another one, a less than, x is less than -1. That means any number smaller than -1 is going to work for that inequality. Again, here's -1. I'm going to draw a circle, an open circle, and then kind of highlight that line, make it darker towards the negative infinity. Okay? Let's look at greater than. X is greater than 1. So notice where, it's not less than. Again, we're reading left to right. X is less than 2. Here, x is greater than 1. Okay? And notice the point is pointing to the smaller number. Okay? So, first we're going to identify 1, which is here, and because it does not have the equal component, equal to component, we're just going to have an open circle. Now for this inequality, this solution states that any number larger than 1, like 1.1 or 1.002, that would be larger than 1. That would be a possible solution. So we're going to darken the line that goes to infinity in the positive direction. Okay, let's do another one. Let's say we have x equal, or not equals, is greater than a -3. Okay, here's -3, open circle, any number larger. Okay, so 2 or -2.99, that's going to work. Any of these numbers are a possible solution. All right, let's keep going. Let's now work with inequalities or solutions that have an equal as part of the answer. So we're going to say that x is less than or greater, or excuse me, less than or equal to 4. X is less than or equal to 4. So with these others that did not have the equal to as part of the solution, we had an open circle. Okay, instead we're going to have a closed circle. So first let's find 4, positive 4. We're going to make a circle, but we're going to fill it in. It's a closed circle. Okay, now x is less than 4. Okay, we just took care of the equals by coloring it in. Now it's less than 4. So I'm going to go in this direction to the left towards infinity on the negative side. Okay, let's do another one like that. Let's say x is less than or equal to 2. So I'm going to find 2 and color it in because this is my equal to 2. Or, excuse me, let's make that -2. So -2, color it in. Any number less than 2 is going to go in this direction. All right. So these numbers are smaller. We're moving away from 0 in the negative. That makes them smaller. All right, let's do a couple more, but we'll work with instead greater than. Let's say we've got x is greater than or equal to 3. Again, we have an equal to 3, so that's going to be a closed circle. Color it in. Any solution larger than 3 is going to work, so that's why I want to go to the right. Okay, 3.01 is a solution. 9.5 is a solution. Okay, so we're going to show in that way. Last one, x is greater than or equal to -2. So find -2, make a closed circle. Greater than means we're going to the right. Any number larger than that -2 is a possible solution. Okay, so notice when you have the equal to as part of the comparison symbol, we're going to have a closed circle. Okay, now in the next video we're going to actually go through solving inequalities using the different principles that we've already been practicing. And really it's not going to be any different. There's one exception, but if you understand this graphing, we're going to do a little bit of graphing once we find our solution. So you'll get additional practice. As always, if you have questions, bring them to class. We'll talk about it some more.